Welcome to AP Environmental Science. In this video, we are going to talk a little bit about fossil fuels and how we can turn fossil fuels into actual energy. So some of our main topics include how fossil fuels are formed, how combustion actually works, so that overall chemical process, the burning fossil fuels and turning them into energy and how that process works, along with a brief overview of the extraction methods and the environmental consequences of using fossil fuels for energy. Now, to begin, all fossil fuels really use this same generalized formation. Now, to change between coal versus oil versus natural gas, it really depends on our starting material. And we talked about the starting materials for coal being peat, whereas the starting material for oil and natural gas tends to be aquatic or marine organisms. So what happens is our organic materials are collected at the bottom of a water body or in a particular location, but there's not really any decomposition taking place. And typically that's because it's an anaerobic environment. And then over time, some sediment comes over the top of it and we compress, so that heat and that pressure, that is going to change that chemical structure and it will cook the original biomass and turn it into fossil fuel. Now, once we have that fossil fuel, we can then extract it and then burn it or go through the process of combustion to release the energy that's stored in that fossil fuel itself. Now, combustion is a chemical process, and this is really just a fancy way of saying we're burning that fossil fuel, and we're burning in the presence of oxygen. And in the process, we are producing carbon dioxide and water as the waste product, so to speak. And remember, our fossil fuels are coal, oil, and natural gas, and all three of these can be combusted or burned in that same manner. Now let's briefly review how we get the coal out of the ground, and that is through mining, and that mining can be surface or subsurface mining. Remember, surface mining could be something like mountaintop removal or strip mining, are kind of the two main ones we use in the United States. The subsurface mining, this is digging those tunnels and having this large equipment boring holes through the earth, really following those coal seams in the bedrock geology. Then once we extract the coal, then it goes to a power plant. Now on this diagram, I have a generalized overview of a coal-fired power plant, and this is looking at a specific plant in Georgia. Now just keep in mind that there are a few different setups of coal-fired power plants, but all fossil fuel power plants follow the same schematic, where we start with burning our resource to then create heat, and that heat turns water that's in a pipe into steam. That steam then goes to a turbine which spins and powers a generator, and the spinning of that generator produces the electricity. That's it. That is our overall generalized plan of how to turn fossil fuel into electricity. Now, in a coal-fired power plant, there's a few other steps involved. We first start by pulverizing the coal to turn it into an ash or a dust, and then that dust is what is burned, and we have that smokestack where the pollutants, so that carbon dioxide and the gases, all kind of go out the smokestack. In a modern coal-fired power plant, we have some pollution control devices to remove some of that atmospheric pollutants from the original stack. All right, so that heat warms up the water that's in those tubes, and that water in the tubes becomes steams, which then goes to the turbine. In the turbine, that steam spins it to generate the electricity, and after that steam really kind of loses its oomph, or all of its kind of real go juice there, it starts to cool and condense, and it kind of falls down out of that turbine. And then it goes into what's called a condenser. Now this is where we have a loop within a loop setup. So we can have this secondary loop of water that goes out to a cooling tower that can cool the water that's in this condenser before the water goes back to the actual heating part in the boiler. The Cooling tower is this large kind of tube, almost like a cone kind of cylinder there, where you have a bunch of pipes wrapping their way around the inside of that cylinder. Now the inner part is hollow, and the idea is that the heat from the water will dissipate out through the walls of the cooling tower, and what looks like smoke coming out of the cooling tower is actually just this warm air that is holding a lot of moisture. So that's just water vapor coming out there. Now there are some problems with burning coal for electricity. First of all, mining coal leads to all sorts of issues that we talked about in our mining unit, or the mining topic section of our previous unit. Also, pulverizing or breaking that coal down into dust. The dust is highly flammable, and the dust is a respiratory irritant, so a lung irritant. The water that is used for cooling is oftentimes warmer when it is then released back into the environment. And remember, there are organisms that have a very narrow range of tolerance, which means they're not able to survive outside of a certain temperature range, which means if you have warm water being released into a water body, that can change that overall temperature and lead to an alteration of the habitat. Additionally, burning fossil fuels releases carbon dioxide, and carbon dioxide is a greenhouse gas. And this also releases other air pollutants, including mercury and sulfur, which can lead to acid rain. Now, there is this thing called clean coal, and I like to use air quotes with it because it's not really that much better. Yes, there is an improvement. However, we are still burning a limited fossil fuel, non-renewable resource. So it's not perfect, but it's a little bit better. And we can do what's called fluidized bed combustion of coal, where we're mixing the coal with some limestone in that boiler to try to reduce the amount of sulfur emissions. So good job there. We can also use some pollution control devices on that smokestack to capture particulate matter and to remove some of that carbon dioxide emissions. But here's the catch. It's really expensive to retrofit or to upgrade some of these older coal-fired power plants. So a power company is not going to do this on their own, because if they have these pollution control devices, that's not causing them to generate any more electricity or increase their profits at all. So it really takes a community-wide effort in order to put pressure on these companies to actually do these initiatives, or it also takes some government regulations stepping in and putting in fines for not following these types of regulations. Now again, briefly, I want to review oil and natural gas tend to form together, particularly from biomass that was accumulated at the bottom of the ocean. And then over time, heat and pressure creates that oil and natural gas. In order to extract this, you use wells. So a oil well is going to extract that liquid oil from the ground, but a gas well only is able to really extract the gas that's sitting on top of the oil. But we can also do what's called fracking, or hydraulic fracturing, in order to extract natural gas that's actually stored inside shale, which is a type of rock. Now, hydraulic fracturing is a fascinating process. It's a marvel of how scientists were able to figure out how to do this, but it also leads to some serious environmental issues. We'll start here with the process of how to do natural gas fracking. What happens is you drill a well down into the ground and you line it with clay. Remember, clay has very small particles, which means there's very little pore space, very little permeability. So this is a way to protect that aquifer that you're drilling through from any of the liquid that you're pumping into the ground or from any of the gas that you're trying to extract. So you line that hole with clay, you insert a pipe, and then you pump in what's called fracking fluid. Now, the fracking fluid contains water, but it also contains sand and some other chemicals to help with lubrication in the pipe. And what happens is, as you force that fracking fluid down, it creates pressure that causes some cracks or fractures to develop in that shale that is your kind of target material here. And those cracks are held open by the sand particles. and the gas is going to follow the path of least resistance. So it will then move into that pipe that you inserted into the ground that you just pumped a bunch of fluid into. So what happens is then that gas flows back up the exact same pipe, and then it is captured and then sent down a pipeline and out to the consumer. Now again, there are environmental issues associated with fracking. First of all, building these well platforms destroys habitat. And in my next slide, I have a picture of the way that these are dispersed across the landscape. Secondly, if that pipe is not actually lined properly, that fracking fluid can get into the aquifer, and you can get some of that natural gas leaking out into the aquifer, and that's bad news. Also, fracking fluid contains volatile organic compounds, which basically means that it's a compound that vaporizes or turns into gas at room temperature. And oftentimes these VOCs lead to some pretty serious health consequences. Now, not all of them, but some of them can make you really, really sick. Natural gas can also leak out of the well or leak up from those fractures into the groundwater. And this has led people who live near some of these fracking operations to have some pretty serious issues with their drinking water. Additionally, and this is the one that is fascinating and was not initially expected as an impact, is all of this fracking of the bedrock here can lead to earthquakes. So we're really destabilizing the foundation of the earth in this area, and that can activate faults that have not been active for a long period of time. Again, there are other problems with the other fossil fuels in their extraction and combustion processes. We talked about the problems with coal mining in our previous unit. And again, oil extraction and natural gas extraction, that's our picture on the bottom here. You can see all of these extraction well platforms scattered across the landscape. So this really fragments the habitat. Additionally, the transport of this oil through pipelines has the potential for pretty destructive oil spills, and the natural gas extraction can lead to contamination of drinking water. Additionally, all of this fossil fuel combustion is altering the carbon cycle. So we're taking carbon that was stored in these fossil fuels, buried underground, and now we are changing it to be part of the atmospheric carbon dioxide. So we're disrupting this natural balance. Now, in summary, and my goodness, I know I went fast through all of this information, you should be able to explain the process of combustion and the process of turning a fossil fuel into energy, so looking at those steps in a generalized power plant. You should also be able to explain some of the methods used to extract fossil fuels and some of the environmental consequences of using these. Again, please send me your questions here at the end, and I hope that as you watch this video, you were able to learn something.